Alright, so this is going to be kind of a special video today. I want to talk about making a super simple rock, paper, scissors game, specifically in Java in the case of this video, using systems of equations. So there are many different ways, obviously, that we can create a really basic rock, paper, scissors game. If I open up my VS Code here, I already have a pretty typical example of what we might do. So in this case, we have a user input, a computer input, and I'm just calling rock, paper, and scissor R, P, and S. So I'm just shortening that for the different kind of game moves that you can choose. And here we just have a super basic switch statement with a whole bunch of if statements and else if statements. And this is just fine for rock, paper, scissors because it's a really simple game and there's not really much that we're probably going to be editing or changing or adding to in this program. But just for fun and just for scalability, maybe this could apply to other kinds of programs or other kinds of games similar to this. I want to explore another solution, an alternate solution, of how we might go about doing this. So one way is using systems of equations. And so the cool thing about rock, paper, scissors is that we can kind of treat them as independent variables that we can add together to create some output state. So we have kind of like two different inputs, right? We have the user inputting like maybe rock, for example, and the computer maybe inputting scissors, and then we can kind of add these two states or game moves together to get some kind of output state. And the output state is whatever the winning move is. So in this example, if the user input, I'm going to put U here for user, if the user inputs rock and the computer inputs scissors, then we should be able to add these two variables together and get some output, and the output would be the winning move. So in this case, rock beats scissors, so the winning move would result in R for rock. So what would this look like in a more mathematical kind of system? So the first thing we can do is start creating our individual equations. So we know that R plus P, rock plus paper, the winning result should be paper, so that could be P. We want paper plus scissors, the winning result here would be scissors, and rock plus scissors would be rock. So this is basically the foundation of what our system would look like here. But it's still a little bit vague, right? Like P, S, and R, they're not really numbers, so we can't really do anything with them unless they represent like a numeric kind of value. So we want to change them into numbers. We don't want to actually have non-numeric values here because then we can't mathematically solve this system. So now the question is, what numbers then do we put here? What do we substitute P, S, and R for in order to solve for these variables? And the answer to that is, well, it really just depends. Like, there's actually two ways that come to my mind immediately. One is that we can kind of, I'm just going to cross these out. Actually, no, hold on a second. I'll just edit this. The first thing that comes to mind is we could replace these with just counting numbers. And these counting numbers could correspond to maybe some position in a list or array that contains all of the winning moves. So what I mean by that is, let's say, for example, I have an array that contains like R for rock, P for paper, and S for scissors. Right? And so each of these indices for each of these elements would be rock would be at 0, paper would be at 1, and S would be at 2. Let's kind of change these into arrows here. And so these could be the values that we replace in our system so that they correspond to the winning move in the list. So for example, if the user rolls, and I'll actually just kind of label this here, we'll put U for user and C for computer here. If the user rolls rock and the computer rolls paper, then the winning move should be paper, right? And so what numeric value can we substitute for paper? Well, paper is at index 1 in our list, so we could put a 1 here. If the user rolls paper and the computer rolls scissors, the winning move should be scissors, and scissors is at index 2, so we could put a 2 here. And again, you kind of get the same idea. Rock and scissors. Rock is the winning move, which is at index 0. So now we can actually solve this system for each one of these variables. And once we get the numeric values for each one of these variables, then we can add any combination of them together, and their result, their sum, will give us what the winning move is in this list. So before I share that, let's just go ahead and actually solve this system, which is super basic. So let's say we can just basically start by writing P in terms of R, so we'll just solve it from top down. So if we have R plus P equals 1, then P is just 1 minus R. If I substitute P in for the second equation, that's just 1 minus R plus S equals 2. And now we can write S in terms of R. So we can say S, you'll have to forgive my handwriting here, S is equal to 2. We're going to subtract 1 on this side, or from both sides, so we can kill the 1 here, and this will now become just a 1. And then we're going to add R on both sides to kill it on the left. So we see that S is equal to 1 plus R. We still have our P up here. And then we can just go ahead and plug the S in to the bottom equation, which would just be 1 plus R plus R, which I'm just going to go ahead and simplify right now to 2R plus 1, and we know that that equals 0. And then we can just solve for R. So let's go ahead and take away 1 from both sides and then divide by 2. So R is equal to negative 1/2. Alright, and now we can just substitute R in for both of these other equations here, and then get their respective values as well. Alright, so once we do all that and we substitute R in for the rest of our equations, then these are the 3 values that we get. So now I can combine, or I can add together, any of these variables, and the resulting sum will be their index in this solution array, or this answer array, or the winning array, whatever you want to call it. So just as an example, let's say that I want to take paper and let's do rock and scissors. So rock and scissors is negative 1/2 plus 1/2, which equals 0, right? Between rock and scissors, rock wins. The answer is 0, corresponds to 0 in the list. So I think you get the idea by now. So that's one kind of solution that we can use. In Java, I feel, and I'm still kind of a beginner in Java, so there might be better solutions. But I feel like with creating arrays or hash maps and stuff like that to contain or to map these variables to what their equation solutions should be, and then looking it up in like a lookup table or a lookup list might be a little bit excessive. So there's another cool thing that we can do here, which I think is a little bit more complementary towards Java specifically, and maybe other languages as well. Instead of having the answers in our system corresponding to some index in a list, we could actually just make our answers correspond to the bytecode value of whatever the winning character is. So for example, I'm going to have to pull up my ASCII table here. So in our ASCII table, we can do here is we can let the solution to each individual equation be the bytecode value of the winning character of the winning move. So for example, rock Between rock and paper, paper wins, so we want our answer to be like maybe the letter P, but in bytecode. So P in bytecode is 112. So that's 112. Between paper and scissors, we want scissors to win, so we want to get S in our ASCII characters, which is 115. And then between rock and scissors, we want rock to win, and R is, the ASCII code for R is 114. So now we have a new system that we can solve, and I'm just going to skip to their solutions, because we already know how to do that. Alright, so once we solve that system, these are the values that we get. And the really cool thing about this is now we can add any of these three variables together. And I'm sorry, this should be S for scissors down here, not R. So we can add any of these three variables together, and then the result of that sum will be the bytecode of the winning character. So if we take, let's say, rock plus paper, which is the same thing as 55.5 plus 56.5. I'm going to try to do this in my head really quick. It should be, let's see, this is 55 and 55 would be 100. So that would be 111, 112. So 112 is the bytecode, and if we convert this back into a character, let's look at the ASCII table again real quick. That would give us P. So this is really cool because this is kind of a way to shorten our way of comparing. In fact, we don't really have to compare anything at all anymore. We don't have to do comparisons between, like, if, going back to our switch case example, right? We don't have to compare to see if the computer input is P, if the user input is R, and all this other kind of stuff. We can just add values together and then use the result to determine the winner. And so I actually have a coded up example of that here. So just a before and after kind of comparison. This is what we had before, not using systems of equations, and then this would be using the systems of equations and bytecode solution. So what we have here is a game states array, which just holds, again, I'm still a little bit new to Java, so there is probably a much better way to do this. I'm just kind of using an object, a 2D object array here to store these values in an easy fashion. And then I'm sure that there's a method that we can use, or maybe a different data structure for looking up values in a list. So I had to create a method for kind of searching for a certain kind of game move in this array. Anyways, that aside, I just kind of wanted to explain myself here. The main concept of this solution is we have the answer solutions for our game moves in this array, and we can look up the corresponding value for those whenever we have a user input some game move or a computer input some game move. So for example, if the user inputs paper in this case, then we're going to look up paper in this array, and we're going to find what its corresponding value is. And the same thing with the computer. So we're going to get the 56.5 for paper and 55.5 for rock. And then all we have to do is just add these values together. So that's all we're doing here, is just adding them together, which should be the bytecode of the correct solution. And so then we convert that bytecode into a character, and then convert that character into a string, and then we can just say, and then store that inside the result, and then we can just say, if the result equals the user's input, so user bracket 0 here just means P, which is what the user input. If the result is equal to what the user input, then that means that the user is the one who won the game. If that's not the case, then that means that the computer won the game. And of course we have a edge case up here for if the inputs are equal, then we can just say that it's a tie and do some other logic handling here. But you know, the main logic here and the main concept of this solution is the fact that we can add these two variables together, and then that will give us the winning result, which we can then compare with the user input or the computer input. So that's really it. That's kind of all I wanted to cover in this video. I just thought it was a really interesting concept. I had a problem come up where I had to make a rock, paper, scissors game, and this just seemed like a really neat way of thinking about it. And so that's pretty much it. Thanks for watching.